Today we are going to discuss the signals and systems, very important subject in terms of GATE examination. They given total 8 sessions to me, 8 into 3. So almost 24 hours they given for me to complete the signals. Yes, these are the main 8 topics in the signals and systems, where I am going to cover each and every topic in each and every session. Today, the first topic, introduction to signals and systems, will start. I will try to introduce the course, what is the actual system in general, and what is a signal in general, and what is the relation between the signal and system. And then we will see some basic operations on the signals like shifting operation, scaling, time reversal, and then we discuss about the basic signals like impulse, step, as well as ramp signals, and how to represent the normal signals in terms of step signals, ramp signals, those points we will discuss in this lecture mainly. First, try to listen the class and try to maintain the notes. It's very important. In the end, anyway PDF material will be available. First, try to listen the class in full length. If anyone is having the doubts, after each and every topic, I will give you 5 to 10 minutes, how much time you want, I will provide you to give the answers. So, after every 45 minutes to 50 minutes, we have the doubt session, so don't bother. Try to listen the class and try to maintain the notes. So, first of all, write down the topics, what I am going to cover in signals and systems. These are the topics I am going to cover in the signals and systems. Please note down the topics. Then we will forward. Just off minute. Please note down the topics in signals and systems, what I am going to cover. Please maintain the notes. It's very important. Definitely, from the signals and systems in GATE examination or whether ES examination, the questions will come from the what we are discussing on the board. So try to maintain the notes and follow the concept. So when you take the signals and systems in GATE examination, almost 10 to 12% weightage is there in the GATE examination. I will discuss about the GATE examination on a minute. So 10 to 12 means almost 10 to 12 marks will come from the signals and systems. That too, it's a very basic subject where you can get the more score. Yeah, for EEE, for instrumentation, for electronics and communication, for all the branches, the same syllabus is there. These are the topics we should note down for all the branches. For EEE also, the last year 10 marks came from the GATE examination. So what I am going to discuss is valid for all the 3 branches. They given instrumentation, EEE, and electronics and communication. Now, what are the standard books we have to follow? I cannot prefer at this time or at this point of time the books, but because we don't have that much of time, so try to maintain the notes and practice the questions what the GATE Academy is providing. That will be sufficient for the at this point of time. But anyway, if you want to go with the standard book, I can refer A.V. Oppenheim. You can purchase the second or third edition. I can prefer the second edition, you can purchase. So Prentice Hall Publications of India. So for the standard book, if you want to refer, you can purchase A.V. Oppenheim and practice the end problems. So whenever you are getting up difficult with the solving the end problems, then anyway the academy will help you, or anyway in the end I will provide my mail ID, then you can send the questions, we will solve. But anyway, if you want to go with the standard book, you can go with the A.V. Oppenheim. And whenever it's a small example I want to discuss with you. Suppose This is valid for the electronics people. Suppose we have the subject like communication systems, where whenever we handle the that's too much weightage is there for the communication systems. Whenever if you want to handle the questions with the communication systems, where signals and systems will play a very crucial role. Why crucial role is, if we know the communication concepts also, you cannot solve the question without knowing the signals concept. It's interrelated itself. So, if you want to perform well in communication, you should follow in the signals and systems. That is for the electronics. Of course, for electrical, it's not there. For instrumentation, some other communication topics are there. So, the signals and systems is very, very basic subjects. So, try to follow. Definitely, you will get the questions what we are discussing on the board. So, let's start with the topics. The first topic, introduction to signals and systems. Let me take what is actual system in general. So whether it is a physical or biological or electrical system, whatever be the system, if I represent with a box, then the definition for the system will be like this. It is a meaningful, the general definition, it is a meaningful interconnection of physical devices and components. It's a meaningful interconnection of physical devices and components. What it means actually? What it means actually is, suppose, I think all of you know about a low pass filter. Low pass filter. What's for constructing or for designing the low pass filter? What are the components I need in general? Yes, tell me. For constructing the low pass filter or for designing the low pass filter, what are the components we need? We need one capacitor, and we need one resistor, and we need some connecting wires, as well as we need breadboard. These are the four components I need to design a low pass filter. Yeah, now it's clear? Okay, let's see. I want to design the low pass filter. Clear? So to design the low pass filter, what are the components we need? Of course, a capacitor and one resistor, connecting wires and breadboard I need. Suppose if I put all these components on some bench table, try to listen carefully. If I put all these components on some bench table, can I say it is a low pass filter? Can we say it is a low pass filter? No, it is not a low pass filter. When we can call it is a low pass filter? Whenever if we connect the resistor in series with the capacitor, then we can call it is a low pass filter, where we are applying the input here and we are taking some output here. So whenever if we connect these components in such a manner, then we can say it is a low pass filter with some high time constant, whatever it may be, leave it. If I connect the components in this manner, then I can say it is a low pass filter. So what you understand from the system? System means it is a meaningful way of connecting the components in such a manner it should form a meaningful system. Let's take the more general expression, more general example. Suppose if you are listening the classes in a studio where the chairs are there, the chairs are meant for to sit the student to listen the classes. Suppose if the chairs are upside and down, is it possible to the students to sit and to listen the classes? It's not possible now. So it is not a system. So why? The system means it's a meaningful interconnection of the devices in such a manner it should form some meaningful information. That is the general meaning of a system. It's a meaningful interconnection of physical devices and components. Now, I have a system or I have a low pass filter. I am not applying any inputs or I am not applying any input signal. What I am not giving any input. So, can you expect any response or any output from the system? Or can you get anything from the system without applying any input? Or you can take some more general example. Suppose I have a electric motor on the laboratory floor. Can I get any output from the electric motor if you are not excited with the electrical voltage? We are not getting anything. Here also, the systems by itself, they cannot achieve anything. They cannot achieve anything. So, the systems should be more interrelated to the one term that is called, it should be more interrelated to the term called signal. So, whenever if you excite or if you give a signal as an input to the system, it's called input signal. Then system will take that one, it processes the signal and it will produce another signal. Of course, it is called output signal. So whenever if you give the systems are related with some signals, then only it will be useful. It will produce another signal. Of course, that is called output signal. So you may ask the doubt, sir, what is the difference between the input and output signal? Both are signals are only. The difference is the output signal. What is a signal? I will discuss. The output signal will have some good characteristics or will have some better characteristics. What I want or what I need, the type of characteristics that has been involved in the output signal when compared with the input signal. That is, the output signal will have some desired characteristics what I need when compared with the input signal. Let's take the small example. I have a electric generator I have. So I have in my class, I want to switch on the lights and fans in my classroom for the students. So I have the electric generator. I don't have any power. So that electrical generator, I can call it is a system. But what is the output I need from the electrical generator? I need power. I need power from that electrical generator. So what is the input we need for that electrical generator? Some diesel I need. So where the diesel I can pronounce, it is the input signal. The electrical generator is a system. It takes the input, it processes it, and it produces the electrical current as the output which I need in that case. So I think you cleared about what is the signal, what is the system, and what is the difference between the input and output signal. Clear? You've taken these points. Let's see. Now, let's discuss what is the actual small definition for the signal. In general, the definition for the signal is, it is a dependent, it is a dependent variable on some, it is a dependent variable on some independent variable. Or you can take one more definition. Let me write the definitions, then I will explain it. I can write one more. Any quantity associated information any quantity associated information within it is also called a signal. Let's take what is a signal definition I given. It's a dependent variable. Suppose let's take any signal. Suppose I have some signal x of t equal to some a into sine t I have. So if I plot the signal like that, the signal will flows. It's a peak amplitude is a versus time. Here it's a dependent variable, means here the amplitude is a dependent variable and depending upon the some independent variable time. Here this what it is producing, what is the information it is giving, its amplitude information as well as its frequency information it is giving. So any quantity is associated some information within it, we can call it is a signal. It's a dependent variable, of course the amplitude. It's a dependent variable on some independent variable time. So it can also pronounce it's a signal. The signal, what is the meaning of signal cleared? It's still the number of definitions will come. But at the starting point, I'm giving the general definitions. Whether it is an input signal or output signal, I will represent the signals in terms of functions to analyze it. So it is a function of whether one independent variable or number of independent variables. But in our signals and systems, we'll take the independent variable is the time. So we'll represent the signals in terms of functions where t is the independent variable. Of course, the output is also some function of same independent variable y of t. I think the concept of what is a system is clear, what is a signal is clear, and what is the interaction between the signal and systems also clear.